starting from some sort of basic design, showing you some of the design accelerators that we have, some little bits on the drawing environment. So as we move forward, hopefully you'll get a good feel of what the product looks like and what capabilities we have. Okay, so in this example, I'm going to kind of show you some basic design. We've got this frame structure where we're going to create a tank vessel and place it on top. We're also going to go through and show you a lot of things on the frame generator. So how we can create frames, how we can analyze them through simulation, and using some automation on top of that as well. Okay, so here we have our top level drawing for our assembly, and we have placed some basic views here and annotations. What I'm going to do here is I'm going to actually open my assembly directly from my drawing. Now the important thing to understand here, for if you haven't got Inventor or never seen it before, we have interoperability between our DWG files and our actual assemblies. So any change I make in this model here will reflect automatically in my DWG file. Okay, and the first thing I want to show you here is starting with some basic Inventor sort of part modeling. So I'm going to create the vessel, the tank vessel that will go on top of the skid here. Okay, I'm going to start a new part. I'm going to start a new sketch. Now, if you're coming from a 2D background, 3D is not very hard to adopt. We're still using our 2D knowledge in here to create. Everything has to start from an initial sketch. Okay. So we're going to start by creating a rectangle here just to start creating our tank. I'm going to set this line into a central line and create an ellipse circle. Do that again from the bottom to the top. Okay, we'll deal with AutoCAD. I will extend my central line to the other end and start trimming some of the lines that I don't need. So effectively what I'm trying to create here is the top level, is the top left quarter of my tank, and then once I've done that, you will see I will revolve the whole thing around to create the final shape. As you can see, I'm not placing any dimensions yet. Let's click on and start placing some dimensions here. Actually, I'm going to start with this side here. Okay, this now Inventor knows that this is going to be a radial, so it's going to basically give me the the radius of my entire tank. So I'm not going to worry about the value just yet. I'm going to place another dimension on here for my ellipse. And the power of Inventor, as comparing it to AutoCAD, which is sort of direct input, is that we have parametric capabilities. So instead of me just typing a value for this dimension, I can actually point it to the value that I've already placed, the dimension I've already placed previously. And I'm going to use a very simple sort of equation to define a dimension for this shape here. Okay. Now I'm actually going to change this. I don't have to use millimeters. I can change any units I like. So I'm going to set this to 2.5 meters. So I've got my initial shape. Okay, and we're going to place one dimension here at the bottom. Again, I'm going to point it to my previous dimension and just to multiply it by 2 and take away 1.5 meter. And you can see my sketch has turned blue or purple, if you like, and this means that my sketch is fully constrained, so there's no degrees of freedom to move around. Okay, so let's finish. That was our initial sketch. Let's zoom out. And now I'm going to move into my 3D environment and pick some of these profiles here and actually create a revolve feature, as we call it. So effectively I created the front bit of my tank. Okay, really quickly and easy to create that. We can then cell the shape here, so I can create I can see the inside and set the thickness to 15, so we can see all the way through inside the first half of our tank. Now I want to create the nozzle at the front, and the way I'm going to do this, I'm we can create sketches anywhere we like inside the 3D environment. So what I'm doing is I'm creating a plane, and I can use the transform handles to point it to where I want to be, or I can say I want to show dimensions of my initial extrusion. Sorry about that. Let's do that. Show dimension. I'm going to pick the dimension that I had here, and I'm going to set it to minus. So effectively I'm creating a plane that's tangential to the front ellipse circle there. And I'm actually going to push it further for 300 millimeters. So I've got a custom work plane, and I'm going to create a new sketch here. So I can create the nozzle at the front here. We're going to create some circles. I'm going to create one and then offset a few of them. So this circle is going to be for where my holes are going to go, and another couple of circles are going to be the neck that will connect to my tank. I'm also going to create a couple of reference lines that will help me place the holes for the bolt connections. Okay, so no, I'm not using dimensions just yet. Let's start placing some dimensions on here. I'm going to set that to 715. You can see the rest of them are updating because I've used the offset command. I'm going to use that and point it to my first one, and let's say I want to take minus 107. And this, because this is going to be where my holes are going to go, I'm going to set this to construction. And then as for the neck, let's place a dimension here. And I'm going to point it to this dimension here and take away 100 millimeters. So it's 100 millimeter distance from that. Now the thickness for my neck is going to be 8 millimeters. Okay, so really quick sketch. Let's take away the visibility of my plane and start using my 3D commands here to create the shape. I'm going to pick the neck, and I'm going to say I can use the transform handle to kind of pull, or I can say very cleverly say two necks, so it's very nicely going to fit my shape at the back, and press OK. Now you'll notice my sketch has disappeared, but I can bring that back into play, so I can continue creating some of the extrusions. So the next thing to do here is to we've created the neck. We're going to set this to, let's say, 25. Actually, not to make it a little bit thicker there. Okay, so effectively we created that, and the next thing we need to do is to create the holes. So we've got hole commands that we can point it to a point in my sketch. Okay, and I'm actually going to use my mechanical or engineering details. So Inventor is very clever. It knows this sort of standard that I want to use for this bolted connections here. So I've got my different standards that I can pick from. I'm going to use my ISO standards and change that to hex head cap screw here. And I'm going to set the size to, let's say, M30. So this is information that will be kept, and Inventor will know when I want to create a bolted connection, it will know exactly which bolt I need to place on there. My termination for this hole is going to be the back plate here. And once you can see the preview, it means you're in good track, so that's going to work nicely. Okay, so we've created the first one, the first hole, and I want to pattern that using a circular pattern around this axis here for, let's say, 20 holes we want to set for this. Okay. Now the power of parametric, of having a parametric modeler here is that I can always go back to my sketch that I had previously, and I want to place a dimension here to define the distance between the holes that I have here. And again, I'm going to use a very simple equation. I'm going to say 360 divided by 20, which is the number of holes, divided by 2. That will effectively give me a 9 millimeter distance for that. And you'll notice that Inventor automatically has repositioned the holes on here. Okay, let's create another extrusion. I'm going to pick the middle circle, and this time I'm going to cut to next. So effectively I've got the hole, and I can look all the way through my model. Okay, we don't need the sketch anymore. We can turn the visibility off. Maybe when we create some chamfers for this, let's set this to 25. Put one at the back here. If we want to create proper welds, we can put this into an assembly and create proper welds for this, but I'm just showing you the part environment in this case. Now, obviously I need to create the rest of my tank here. If I try to mirror that, I've left that in purpose. We can't do that because of the cell feature that we have created here. But I've done that in purpose because I want to show you again the power of Inventor. We can move our end of part all the way to the beginning where I just started and did my initial revolution. And I'm actually going to mirror this now. I'm mirroring this revolution feature, and I'm going to use my origin plane. So effectively I've got the entire tank. And I don't have to recreate the rest of the features. I can simply move my end of part to the bottom, and you can see my tank has now been created. Okay, let's give this a material here. We can go to materials. I'm going to set it to steel high strength alloy, and Inventor is also giving it a default sort of appearance or color, if you like. Okay. Now the next thing is I want to create the small nozzles that go on the top of the tank. Now I've created features like this in the past, okay, and I want to save myself some time of having to recreate all these features for the top nozzles here. And what you can do with an Inventor is you can create what we call eye features. So eye features are saved features that we can really quickly place again into another shape in a similar shape like we have here for our tank. So let's go into our eye features and pick one of these. Now instead of having to recreate this, all Inventor needs for me to do is to set 3 criteria. So a reference point is going to be my origin center point. My sketch plane is going to be my XY plane that I initially created my sketch on. And my surface is going to be the cylindrical surface here. I'm going to set this to 90 and click next. These are, I'll just move that around. So these are the details, the nominal diameter and the offset that we'll create. If I click finish, you can see the nozzle has been created. I'm going to do the same thing again. Reference point, sketch plane, surface, but this time I'm going to set it to -90. So effectively I've got the other one on the other end. And actually if I go back through my 3D model, I'm going to choose to mirror this last eye feature. I'm going to again use my origin planes, use the XY plane, so I've got another nozzle at the bottom. Okay, so one final thing to create is I want to create a custom UCS. I'm going to actually place it 2 meters below my tank, so that this will help me when I bring this tank to quickly constrain it to my assembly. Okay, so let's save this file. Go back into my workspace. I'm going to name this vessel, let's say vessel B. Okay, so that's really the part environment, just a quick example. What we can do here is we can maybe create a new drawing for this. The drawings are similar. We can have a prompts like we have inside our familiar AutoCAD environment. I can set the scale or I can edit any other attribute within my title block. Now within Inventor, I've got the ability to create base views. So actually let's set this to 1/25. Well, with the new version of 2016 here, we can change the orientation. So we've got actually a view cube here that we can manipulate our model. So we can change the orientation as we like for our initial view. So that looks okay. And then I can create projected views from there. So one here, one there, and maybe create an ISO view at the top. And click OK. I'm going to set the ISO view to shaded, so that we can see that quite nicely here. Let's move these around a little bit. I'm going to edit here and say I want to create this view, the tangent edges, and also show my hidden lines. So you can see we can obviously adapt to our company standards here if we like. Let's right click on this both of these views actually, and right click and say automated central lines. I don't want the whole features. I want to bring any kind of cylindrical revolved features. And press OK. So effectively I've got my nice central lines here to work with. I can start placing dimensions through my Annotation tab, but if I go on a dimension that I've already created when I was designing this, I can say retrieve dimensions from here, select the dimension, maybe I want to pick this here and press OK. So I'll bring that in play. Then we can start creating some baseline dimensions from here to that. Right click and say continue. Place those across. Okay, in a similar manner I can do the left side of my tank. Okay, maybe we want to make this the origin, so I've got a nice equal value here to work with. Right click create. If we look at the other view here, let's create some dimensions, radial dimension for the overall radius. You can see here my different standards. I can add any kind of custom symbols I like, mess about with a precision. Okay, in this case I just want to go ahead and place that dimension. Place my thickness here, maybe move it a little bit around. Okay, so very quick way of creating dimensions, similar to what we have in AutoCAD, but even more intuitive. So for this top drawing here, again I can say I want to automated central lines. This time I want to bring some of the hole information as well, so I can see where the holes are on the nozzles. We've got different types of views we can create. We can create a detailed view. So let's create a detailed view for here. Let's set this to 1/10 maybe, just to round it up, and place that. Let's break the link and make this into shaded. We could even create a projected view from our detailed view. So something like this, and create it here. Let's move this to the bottom. Place another nice view here. We've got the ability to create section views. So for example, I could click section views, click on the view here, and create a central line from here, and then continue. Place that initially. I'm actually going to bring the alignment so I can move that forwards. Okay, and these are live sections, so I can move them. I can edit the section properties, and instead of saying I want this for full, I can send the distance to, let's say, 275 millimeters, and that will automatically update my section view that I created from here. Okay, let's place a dimension for this nozzle and show you a different way we can kind of collaborate for that. So I'm just going to place a dimension for here. I'm going to save my drawing at this stage. And then we're going to export this into a DWF file. Now, DWF files are really good for kind of communicating design changes that we want to make. So let's say in this particular example that we've taken a measurement for the nozzle and we realize that the nozzle needs to be at a bigger sort of radius. Okay, so in this particular instance, in that case, I'm going to really quickly create a DWF file and start creating some markups on here for the other people to see. So I'm going to create a rectangle balloon and say maybe I want to replace this with a 300 NB nozzle. Okay, maybe I want to put a stamp here for, say, rejected. Move that around if we want to put it somewhere nicer. Okay, So then we can either put this through our, email it to the people that are involved, we can put it through our data management system. In this case, I'm going to keep it simple. I'm going to save my DWF file and exit here. So the next person that goes and views the design model has got the ability to go inside the workspace and open the DWF file that the other person has created. And what Inventor does in this case, it overlays it on top so we can see what the changes we need to make. Okay, so we can open our tank here and just make sure so that's the single one at the front. If I look at my eye features, I can edit my eye feature here. And actually we've got the ability to change to different diameters, different standards that we have created here, and press next. Now we'll automatically update the nozzle for me. And if I switch back to my drawing, now you'll see that it has already changed the dimension, it has changed the appearance on here. We can actually go into our action that we had here from our markup and say this has now been done. Okay, and so on and so forth, so you can save this DWF, email it back, showing that this has now been completed. So let's close the markup. Already saved that. Okay, so the next thing to do here is to start placing our tank here inside our assembly. So if I return to my top level assembly, this is the assembly environment and I can place different components in here. I'm going to go into my workspace and bring the new vessel tank that I created. I'm going to place it anywhere in the space at the moment. Just want one instance of that. And I'm going to constrain my two UCS points here to fully constrain that into space. Okay, so this is now, if I try to move that, I can't move that. So if we switch to the other side, maybe we want to bring the nozzle, we want to bring actually the manhole at the front. So I'm going to start placing a new component. I'm going to use some of my libraries here. Let's go to supplier content and look for the manhole cover that I'm looking to bring in. Again, I'm going to place it anywhere in space. And I'm going to use some of our new constraints that we have. I want to create a rigid constraint between the center of this and the center of the nozzle there. I'm going to reverse the direction and then align this. Let's reverse that. That looks okay. Go ahead and press OK to that. Okay, so let's look at this part in particular. Now we've got very quick direct editing capabilities. Now this is an assembly, and I'm actually going to dig through and go into the actual part that we have here. And what I wanted to show you here is we've got even ability to copy features. So I'm going to right click and say I want to copy these features because I want to create the handle here in the connection with my tank and paste it in my tank nozzle. Okay, so I've copied these features. I'm going to return back to my top level assembly, and okay, so let's close this so we can edit our tank in context. You can see all the rest of the parts have been grayed out. I'm going to right click and say paste, and all Inventor here is asking me to create some reference plane similar to what we have in our eye features. Okay, so my plane is going to be my XY plane. My axis is going to be the axis around the nozzle, and my reference point is going to be the center of this circle here. Go ahead and press finish, and here you can see we've created the same sort of handle to make our connection for the manhole here. So I'm going to return to my top level assembly. Actually no, before I do that, let's edit that again. And I want to make these adaptive so they can actually change to when I try to put a constraint. I'll explain what that means. So I'm creating adaptive features, the last two features that I created, I'm setting them to adaptive. So if I return to my top level assembly and, for example, I want to constrain this face to the bottom face and hit apply, because it's adaptive, it's going to automatically know and move these features around. And I'm also going to create an actual constraint between the two. So effectively, I've created the connection for manhole. Okay, so if I get rid of the rigid constraint that I created earlier, or maybe even suppress it, you can now see we've got the movement for the front of my tank. Very nicely we can do that. Let's bring that and suppress that. So very powerful direct editing capabilities here. Okay, so the next thing I wanted to show you here is let's bring on some frames here and bring on the floor support for our tank. I'm going to use my place command again. Let me increase that a little bit. So the foot support, we're going to place it anywhere in space. I'm going to use my normal traditional constraints and put an actual constraint between that and the tank. And also create some flush constraints so I can bring that and align it with the plate. So also this face with that. Okay, so that's now fully constrained. Now, one of the designs accelerator that I wanted to show you here that we have is our ability to create bolted connections. So this is the first design accelerator that we're going to start using. Okay, and we've got the ability to start a bolted connection here. So this is my design accelerator. I've got different options of placement. I'm going to use by hole. So what is my start plane is going to be this. Where's the existing hole? So if I hover on top, it actually picks the hole from the bottom plate, but will actually create the holes for the top one when I'm finished. And the termination for my bolted connection is obviously the bottom plate here. Now, I could go inside my content center here and start picking from my library of different fasteners, bolts that we have. Now here are the basically accessing my content center, the different kind of standards we have. I can filter that with ISO and start picking the bolts and the fasteners that we want. But actually what I've done here to make it a little bit quicker is you can use that. I've saved a template for that. Okay, so if I've got something that I create more than once, I can automatically, that will set the right parts that I need for my bolted connection really quickly. And not only that, but I can say follow the pattern, so that you can automatically follow the pattern in my plate. And don't forget, it's creating the holes for the top plate as well. So really quickly, instead of wasting time trying to set these manually and create the holes, this is what design accelerators are for. Okay. So I guess the next thing here is to create the support on the other side. I'm going to use my pattern. I'm going to pick these three components and say I want to pattern them using that direction. 2 is fine, and I've created some custom parameters to remind me of what the value is for the foot spacing here. And go ahead and click OK. Okay, now inside our environment, we also have the ability to do Analyse Interference. So for example, if I wanted to check if there's any interference for the stuff that I've been creating so far, I can set that, and you can automatically see that I haven't been paying great much deal of attention, and one of the nozzles that I created earlier is actually colliding with my with the support I have for the tank. Okay, so I've got that. I'm very easily able to resolve that if I go inside one of the eye features that we created here. Okay, I'm going to edit this feature and change the offset here. So instead of origin offset, set that to 2 meters. Click next and finish. That will effectively move both the nozzles a little bit further back and effectively resolve my collision. Okay, so at this stage I'm going to save my assembly here. Okay, so I'm migrating to the latest version there. And what I'm going to show you here next is some bits with our frame generator, the next design accelerator that we have. Now Inventor has the ability to create different representations. Now I've got one that I showed you from the start. I've got one for steelwork, which basically it unsuppresses a feature that I've created, like on the top here, for accessing the top of my tank. Okay, and this is quite neat. I'm actually going to open this individually so we can start creating some of the frames. Now the frames generator is a very powerful tool, and as you can see here, the best way to kind of work with the frame generator is to create what we call a skeletal model. So this is simply an extrusion that will give me the basic shape for where my frames are going to be placed on. And the reason for that is that then I can control the dimensions of my entire platform here by just changing the dimensions of this basic shape. Okay, and that will make sense more as we move forward. So let's switch to our next design accelerator and start placing some frames onto this. Now this is the frame generator, and we have our different standards like we normally do. I'm going to use the BSI standards here, the different types that we have. So if I toggle through these, you actually get a nice preview of the different types that we have on here. Okay, the size, let's set this to this. Our material, it can be a different standard material, or we can maybe set this to, let's say, still galvanized, and actually start picking on some of the edges of my skeletal model. If I click on this, you'll see that's not quite the position I want. I want to toggle this, so this is probably the best position for where I want that to be placed. And I'm going to click on the rest of the edges of my reference part here to create my first frames. I'm going to click Apply. Inventor will give me the names of the new parts that will be created. Don't forget that if we had very simple vault capabilities here, we can control the file naming, where these files go, etc. You know, full data management capabilities for that. Okay, so these first frames have been created. I think I've created a space for another T frame here, so let's look for structural T. Okay, I want orientation on the top. Let's set this to default here, and I'm going to pick one of the, I'm not sure if you can see that properly, but you can see it's on the wrong angle. I'm going to set this to 90, that's upside down, minus 90, that looks better. And go ahead and press Apply. New part name, that's great. And one final frame, I want to create the roll bars. I've created a 3D sketch that will kind of show me where these are going to be placed. So all I need to do at this stage is go back into my design accelerator. I'm going to look for circular hollow section called formed. Obviously I want this to be centered in the middle. 33.7 by 3, I believe that is. I could pick individual lines. I can right click and say I want to pick the entire sketch. So this will automatically create these. You can see it's quite nicely placed on there. I'm actually going to merge this into a single file just to make things a bit easier for me. So there's just going to be a single file for that. And Inventor will automatically create roll bars. Maybe I could have changed the material. I don't want that to be galvanized, but that's okay for the time being. And now we're going to start kind of cleaning things up. So we've got very neat tools here where we can use our mitre, if I'm pronouncing that correctly, and we can go around our frame and say I want to mitre these two together. Click OK, so it's created a nice angle for us here there, and do the same thing for the other sides. Let's move on here, move up to the other side, from there to there. Okay, we also have the notch capabilities, which is useful for frames like this. So I want to notch my T-shape to the side frame on this side, and the same thing for the other side as well. So these parts, if I switch maybe to part priority, select other, let's pick my frame here. I'll just show you what that looks like. If I open it up individually, it's created the cuts for us in here. I'm going to save it right now. So I'm going to edit my actual platform because I want to create a pattern for my T-shape. So I'm going to pick this. I'm going to use this as a column, reverse the direction from the other side. Now again, I've created some parameters here, so rounded beam calculation and the beam spacing. So that will effectively give me a nice repetition there. We'll also maintain the end treatments for those. Okay, so that's really quickly how we can create a frame structure like this. If we have the right information on there, so having a skeletal model, we can see how quickly that is to create. And if I was, for example, so let's go back to our assembly here. You can see that has already updated. I'm going to save this at this stage because I want to show you what the bill of material looks like. Okay, a lot of new files really quickly created, reusing a lot of the stuff that we had. If I go under my Manage tab, bill of materials, okay, so this is something that we can export, we can bring it inside our drawing. We've got different ways, so this is how everything is modeled at the moment. So if I expand this, then I get all the relevant files, or we can have a structured version where we can bring in different columns. We have our different frame members that we saw earlier that we created, and all the parts involved, or a parts only kind of interface for that. So this, yeah, like I mentioned, we can export it, we can place it inside our drawing and manipulate it as much as we like. Okay, I'm going to save again, say yes to that. Now, one thing that we're going to be looking later on today is our ability to use design automation, in this case iLogic. And what I've done for this particular ladder, like I mentioned earlier, because I have created a skeletal model, I've got the ability to change dimensions for that. Okay, and what I've actually done is I've created a quick little form here that will enable me to manipulate the size of my entire sort of frame structure at the top of my tank. And let's expand this a little bit so we can see that properly. Maybe set that to the length to 750 and hit apply. Our Inventor would change the entire, will update my different frames, we'll keep all the end treatments, and not only that, but we'll actually add some extra features like the ladder that we can see here. So that shows you the level of automation, and this is honestly was really simple, as we will see on the next session on how to do that. Okay, let's actually I want to run this again. Because actually I want to be able to see the nozzle at the front of my tank. Was that enough? Yeah, I can see that, that's fine. And then I've got a hole to connect on there as well. That's great. Okay, so the next thing I wanted to show you here is we've got the ability to do a lot of tube and piping. Okay, so I'm not going to spend much time on that, I'm just going to show you some of the stuff that we can do in here. So with tube and piping, again, a very intuitive environment. I'm going to edit my tube and pipes here, and I want to create a connection from there to the top of my tank. and also create one of the stainless steel tubes that goes all the way through to the pressure gauge. The way this works is that we have different styles of tubes. Okay, three main categories are rigid pipes and fittings, our tubes and bends, and our flexible hose. And under that, we've got different standards that we can play with. Now, if we want, we could create our own from scratch. All we need basically, so if I show you, for example, a welded steel pipe, this is comprised of three parts: a straight segment, an elbow of 90 and 45 degrees. And when we put this together, then Inventor can create a pipe routing for us. We don't have to create things from scratch. We can always copy that and create our alterations as we like to save some time. Okay, so make sure in here I'm in the right standard. So I'm going to use my BS actually in this case. I'm going to activate this. Let's first of all place a component here. Let's go inside this run. I'm going to place a fitting. Actually, I want to create a T. So here we've got our content center, hundreds and hundreds of different parts that we can pick from according to our standards. This time I'm actually filtering it, just looking at the DIN ones, and want to pick, let's say, one of the T here that I already have. This is an I part, so I've got the different sizes that I can choose from. I can choose using the sort of main tables here for nominal diameter and serial number, but I could actually have the full details in the table view where it gives me all the designation, size designations that I want. So in this case, I'm just going to click the one I know that I can use. You can see how it snaps, automatically snaps to my existing pipe route. I'm just going to create the cut for it and place it properly. I'm going to enter the angle to change the orientation so that it looks the right way, and press OK. So yeah, to connect the connection at the top, I'm going to switch to my part priority, and I want to pick one of these parts that I have here for the socket, and I'm going to, instead of going through my content center very quickly, I can pick on one I've already placed, and I'm just going to reuse that. I want to say I want to connect that to the top of the tank here, and click done. Okay, so that's all I needed. I can now start creating my new route for this connection. I'm under the right standards, and I can create manual sketches, but in most of the cases, actually the automated routing is what I can use. So from here to there, origin to destination, and you can see I'm getting a preview of different kind of options that I have, and I can toggle between them. I can have 5 segments. Actually, probably the 3 segments is better for me. So it's created a 3D sketch for me. I'm actually going to edit the position of this top one and just increase it by, let's say, 400, and I'm going to finish that. I'm going to then populate the route, which will effectively create all the segments for that pipe run. So just to finalize this, maybe switch to my part priority, pick one of these valves, place fitting, and, oops, sorry about that, place fitting, and then just connect it to my pipe here. Okay. As for our rigid, let's create, I'm going to finish this. Let's see where we are, tube and pipe runs, that's great. This time I'm going to change my styles, and I'm going to go into my stainless steel tubing. I'm going to activate this, and I'm going to create a new pipe run for that. And basically, like I mentioned earlier, I want to create the connection from this all the way through to my pressure gauge. So let's start looking at some of the automated features that we have here. I'm going to create a new route. Actually, I'm going to bring my origin planes. Origin planes are useful because I can snap to them, so it will help me with the automated routing to place it through these different geometries. So I'm going to start my route, set my origin. I'm going to come down here, and actually I'm going to right click and say I want to activate point snap so I can snap to the planes. So if we look at my sketch here, this has already, if I click on that plane, you can see it's creating the 3D sketch for me. I want to say perpendicular to this plane. So effectively you can see how this creates the bends according to the bend rules that I have for that particular tube pipe. And I'm going to bring it down to here using the same method, perpendicular to face. Oops, sorry about that. Let's bring that. Okay, perpendicular to face, so it's come all the way down. I know it's going to go through there, so I'm going to go straight into this plane, perpendicular. Click that twice, so all the way up to here. Similar to this plane. And one final thing is my destination at the bottom. Again, I get the different design alternatives. That's probably the one I'm looking for. And that is it. I'm going to finish the route, populate that, and I've really quickly created my rigid tube and pipe. Okay, so hopefully that's given a good idea. That's in terms of tube and piping for this demo. Now, another thing I wanted to show you is a few more things in regards to the frame generator. So I'm going to finish this drawing, finish the model here. Obviously, if I go back to my original drawing that we started with, that will have already automatically updated. It's not showing the tube and pipe because I've told it not to. What we can do is we can go to the original. So if I say that to piping, that will automatically show me the piping as well. Okay. Now the next example I wanted to show you here if we go to our, actually I need to change, I'm not going to save these. Go to that. Let me just switch my project and go under silo here. Let's open up another frame generator example here just to show you how this works. Now again, I've used a skeletal model in this particular example, so this is sort of the conveyor bridge that we're going to be creating, but I wanted to show you some more ways of how we can reuse content and not having to recreate stuff. Okay, so under my design, I'm going to start using my reuse command for my frame generator. I want to create the rest of these frames, structures that I have here. Actually, let's start from the top. So I want to reuse this one and just place it on the other side where I've got my sketch. Go ahead and click apply. Do the same thing. I'll go for this frame to this side. Click apply, so I don't actually have to go into my content center. I can reuse a lot of the contents. I can create some of these frames. If I take one of these, for example, and I want to recreate the top ones, but I want to make a slight alteration because obviously this is going the other way, I can always go to change or reuse. For this particular one, you can see the end treatments were on the wrong side because I basically reused the previous one, but I can always reverse the member direction, which will effectively create the right end treatments for that. Okay, so let's look at the top. Actually, if I switch to the start so we can see what's happening here. And I'm going to reuse again. Let's pick this. and I want to copy it across to the rest of my reference lines. Do the same thing for this side. Go ahead and apply, and you can see how quickly I'm kind of going through building my design here without having to recreate information. Okay, so what we need to do here is start making this look a little bit nicer, so I'm going to use my mitre commands. This with that, so if I click apply, you can see it picks both of the frame members because I've created that relationship between them. And I want to do the same for these with the bottom frames as well. So you can see how it's created a nice angle on this side, and the same thing for this side as well. We also want to notch like we did previously, so all this with there, so it keeps the relationship, so it saves you time for having to do them individually as well. So both sides have been done here. Now you'll notice there is an issue with the top left there. Let's resolve that. If I right click this frame member, I want to break reuse number. And then I'm going to use my mitre again from here to there. Okay, so that looks a lot better now. Okay, and really nice capabilities here. It's because if you look at the other side, I'm missing some of these frames, and again, I don't want to have to create new sketches and start going through the content center. Let's look at what some of these frames here. So hopefully, yeah, so these are the ones. I'm going to actually pick this 4 bottom frames here. And we've got the ability to demote these, or I don't like that word particularly, but we can create a sub-assembly for those particular parts that we can then manipulate. So I'm going to call this cross bracing, just to show you how flexible this is. So this will take those particular parts and place them into an individual sub-assembly. And then we can actually go inside our conveyor bridge and create a pattern, circular pattern of our cross-bracing assembly. What is my axis? My axis would probably be my origin Y. Sorry about that. So sorry, the Z-axis in this particular case. I'm going to set this to 2, and I will set this the direction to 180. So if I look at the other side of my model, this has created the rest of the frames that I needed. Okay, so let's return to my top level assembly here. I'm actually going to switch to my conveyor so I can see my conveyor as well. Turn the visibility off my reference model, and I want to create the other side for this. So again, using my pattern, I'm going to pattern this entire component around a custom axis that I've created here. Use the same method. I'm going to set this to 2 to 180 and go ahead and press OK. Okay, so this is the full conveyor. And not only that, but even with all these changes that I've made, hopefully I'll still be able to use the iLogic automation that I had previously. So with this, I'm basically exposing the reference model parameters that we saw earlier. So the conveyor bit frame, so this one here I suppressed. But by changing these dimensions, my entire assembly will automatically update. Okay, so maybe we can start with the height. Let's set this to 4 meters. This time, as soon as the change is made automatically, and the frame structure will automatically update. Let's change the width here, set that to 1 meter, let's see, just to show you how all these work. Okay, so it's doing a lot of work in the background here to do, and Let's change that to 950. It just needed to update there, so hopefully, yeah, it's still doing something here. Go ahead and press done. Okay, so you can see how easily we can create something that is flexible and agile, and we can adjust it according to our requirements here. Okay, so one thing I didn't get the chance to really show you properly was the last little bit on the frame analysis, which I did want to kind of maybe do a separate webinar for if you need to. But apologies for misunderstanding the time frames I had for that webinar. I thought it was set to 1 hour, and I thought I was already over the time limit there. But let's have a quick look at what the frame analysis looks like. And in this example that we tried to see there was, we've got a frame structure which is also controlled by a skeleton model like we saw in the examples previously. And I want to run some analysis on here to make sure that whatever I'm designing is tending towards the right direction. So I've activated my frame analysis tool, and I create a new analysis. In this particular example, I can maybe simulate with or without the cross beams at the bottom. I'm just going to do with cross beams, just a single analysis to show you how this works. We've got the ability to do static or modal analysis and change the state, like I mentioned, the different level of representations that we have with or without cross beams. Okay, so I'm going to go ahead and test this with the cross beams on. Now what Inventor is doing here is it's analyzing my frame structure and is creating the links between my different components. If we zoom in here, I can see all the connections between the frame members and actually the nodes and the rigid links that were created for this. And one of the first things that we have to do first of all here is to set our our fixed constraints. So my frame is fixed at the bottom with these 4 legs, and I'm just going to create this constraints inside my frame analysis environment. Okay, so the next thing to do here is to just tweak a little bit the relationship that we have for the cross beams here. So for example, if I use my release command, I can highlight some of these beams, the cross beams here, and I can control the constraints that are around these. I can set the, actually I don't want any rotation on the X and Y, but there will be a rotation on the X axis, sorry, on the Y and Z and the X axis. And the same, that is for the beam start, but also for the beam end I want to have the same situation here. Okay, so it's for all these beams I can apply these conditions on here. And also finally I want to suppress the link, the rigid link that is between the two ones, just to make it a little bit more realistic. Okay, so once I'm done, let's have a look. I've got my model browser, I've got all the different nodes, the beams, the links, the release conditions, the fixed constraints, and now I need to start putting some loads into this. I'm going to use the top 6 frames that I have here. Just to, I'm going to actually apply a load. I'm going to click on more options and expand here. Unfortunately, just bear in mind that this data set is set to inches. I need to recreate this. So I'm going to set this to, let's say, 600,000 pounds divided by 6. This is the number of beams that this weight was going to be applied on. I'm going to set it to relative and put 0.5, so that's right in the center of the beam, and click apply, and I'm going to do the same thing for the rest. Oh no, sorry, it's changed to relative and set to 0.5, and do the same thing for the other beams. Okay, so hopefully I will now have 6 forces, including my gravity here. So we can do different things. If we wanted to do something like lifting, we could edit the gravity and change the direction, etc. But in this particular example, we just want that force in those particular frames, just to show you how this works. So at this stage, we are ready to run this simulation. Okay, so this is a bit exaggerated. It's kind of adjusted to multiplied by 5, which is, as soon as the results come through, let me change that to multiplied by 1, so at least we can see what is happening to our frame. We can use our animation tools here to produce an animation and show our results if we want to. Control the speed and the steps. If we look at our results themselves, at the moment I'm looking at displacement. Don't forget this is inches, okay, for the maximum displacement for those particular beams. And we have different types of results that we can inspect. We can see the forces, we can see the moments. The normal stress, probably if we switch to the S max here, we'll control the visibility of the color bar by setting this different maximums. So if we set it to something a bit lower, we'll be able to see better the coloring and the issues that we have in our beams. Okay, so these are the different things, shear stress and different diagrams that we can create. We can probe and look at particular values. So let's look at one of the origins. If we highlight that, and we can get our probe and our values for that. We can have beam details. That's quite useful. We can select one of the beams and see the different forces that we get, the moments. So this is for this beam particularly here. We can look at the S max, shear stresses, etc. And all the results and calculations are displayed on the right, and we can pick any beam that we like to produce this. Okay, so if I actually, let's go for beam detail, and let's say S max or maybe the MX, and press OK. So that will actually be added to my diagrams. We can have diagrams actually on all the beams or selected beams, so we can pick some of the beams here, and let's say we wanted to see the MX for these particular ones. We get the values. We can export that and communicate our design intent. We can put our maximum S max on there as well. Okay, so different things we can calculate, and it will give us a good idea as to whether this frame structure will perform, or whether we're designing towards the right direction. Okay, so these are some very basic kind of simulation tools that you get built inside Inventor. But don't forget, with some very simple sort of additions, for example with Nastra and InCAD, we can do non-linear simulations, we can do buckling, etc., and actually visibly see the results inside our Inventor. But this is more like in a preliminary stage, just to make sure that wherever we're designing is got the right, we're in the right course. Okay, one thing actually I didn't show you here, we can also have the ability to export, generate a report from here. This might take a little bit of time, but it generates views that we want and generates a report in HTML format that we can then communicate internally or externally. Okay, there's a lot of other things that we can do in here. Just going to keep it simple at the time being. If you want to do a dedicated webinar to this, we can